Hello everyone, welcome to my channel. This is Vijay Lakshmi. Today we are going to discuss about learning and its types. So learning, it is a process by which one can acquire knowledge and construct new ideas or concepts based on the experiences. So machine learning is an intelligent way of learning general concepts from training examples without writing a program. So there are many machine learning algorithms through which computers can intelligently learn from past data or experience and identify patterns and make predictions when new data is being fed. So machine learning mainly learns from the past data to make the predictions. So computers can solve two types of problems. So we know that there are two types of problems. One is well posed problems and ill posed problems. So in case of well-posed problems, the computers can solve with the help of specifications and have the following components like class of learning task, measuring of performance, and a source of experience. It can solve only the well-posed problems, but it cannot solve the ill-posed problems. So here we have, in this learning environment, we have training samples, candidate formulae. With the help of the learning algorithms, we generate a hypothesis and compare this hypothesis with the ideal target hypothesis, and then we observe the difference. What is the difference? That is the error occurred between the predicted hypothesis and the expected hypothesis, that is the generated hypothesis we say. So this is the learning model, how the model is going to learn with the help of hypothesis. Learning model makes use of the hypothesis set plus the learning algorithms. So here the model is going to learn with the help of a training samples and a hypothesis, that is the hypothesis space we say. This hypothesis space is nothing but it is a set of all possible hypotheses that approximate the target function. In other words, if I want to say, it is all possible approximations of the target functions which can be defined as the hypothesis space here. Now, consider a sample data set D. Consider a sample data set D where D has some samples like x1, y1 and so on. So x1, y1, x2, y2 and x3, y3 like this with some set of attributes. And let the unknown target function be f, where f is a function from x to y. And the generated target be g, okay, that is the expected one. The generated target be g, which is again a function from x to y, where this x represents the input and y is the output. So in this model, the output can be always yes or no, or we can call it as 0 or 1. And x is nothing but we have a set of inputs here, x1, x2, x3 and so on. So here we can represent this function, target function f, as x of y. This capital X represents a set of possible inputs and y is set of possible outputs. So here when we map the input space to the output space, so the objective of this learning system is to learn from this samples with the help of this hypothesis, that is the candidate formulae, a set of formulas, the set of hypothesis what we are going to represent to make the model to learn. This learning algorithms can be supervised or unsupervised or reinforced algorithms you can make use to generate some hypothesis g of x. So g of x is nothing but again it is a function from x to y. From a set of inputs it is going to give some output. That output can be of the form yes or no. Okay, so here this is the predicted hypothesis, that is the predicted result, and this is the ideal target hypothesis which is the expected result. So the difference in the predicted and the expected, if there is some difference, means that is called as the error. So the model makes use of some of the supervised or unsupervised learning algorithms. It learns through the samples and the hypothesis to generate some hypothesis g of x, and this hypothesis, what is the model has been predicted, the difference in this predicted under expected, that is the target hypothesis, there exists some error. So through this error only the model can learn. So this is our learning environment. So learning model is equal to hypothesis set plus the learning algorithms. So it may predict correctly or it may make some errors while doing the predictions. So what are the different ways that model can learn? There are many different ways how the model can learn. So before going for that, let us assume a problem of predicting a label. Now let us assume a problem of predicting a label for a given input data, or consider a checkers problem. Here in checkers problem, the input is what? The input is the checkers board and the coins. It includes the checkers board and the coins, or the pawns, what we say. So here the simple learning model can be given as summation I is equal to 1 to d, that is d represents the sample data, where xi wi is greater than some threshold, means okay, then it belongs to class 1, that is the label what we have given, class 1. If it is this xi wi is less than some threshold, means then the model predicts it as class 0. So here we have taken a model to predict the input label. Given input label is class 1 or class 0. So what is this xi and wi? This x1, x2, x3 and so on. x1, x2, x3 and so on are nothing but the input vectors, and w1, w2, w3 are nothing but some weights. Okay, and these components might be associated with some bias. That bias is nothing but some error. There might be some error. This bias can be replaced by the variable b. Then this equation can be reduced as summation I is equal to 1 to d xi plus wi plus b. That is the what is the bias introduced. So it includes this. Okay. Next, this, which is nothing but hypothesis h of x. So what the hypothesis we have designed is equal to xi plus wi, xi into wi plus this bias, which can further reduced as h of x is equal to sine of wtx. Okay, so this is called as perception learning model. So this is how the model can learn. If you take the checkers board and coins as an example, means this x1, x2, x3 represents the red color or the black color of the pawn, or the red color of the pawn, or x3 can represent the red color king, or x4 can represent the black color king, like that. And where w1, w2, w3, w4 are nothing but the weights. Same, h of x is equal to xi wi plus b, where b is the bias. So here this is one of the perceptual learning model to check for any of the real world problems. We make use of this learning model. So here any model makes use of hypothesis set plus learning model, learning algorithm to make the predictions, to learn by itself, to make the predictions. Now there are different kinds of learning types. Now till now we have understood the learning environment. So a model can learn from the sample data along with the algorithms to make some predictions. The predicted data might be it might predict correctly, or it might make some errors in classifying the data. So there are different kinds of learning types. One is we learn by memorization. Learn by memorization or learn by repetition, called as rote learning. It is called as rote learning, and is done by memorizing without understanding the logic or the concept. Okay, so here the learning occurs by simply comparing with the existing knowledge for the same data and producing the output if present. Okay, so it can learn, learning perspective is by comparing with existing knowledge for the same input data and to produce the output if present. Or it can learn by examples. Learn by examples. It is also called as learn by experience or learn by previous knowledge acquired. It is called as analogy of learning, or it can also called as inductive learning, learning by experience, or learn by thought, learn by thought. That is learned by an expert or a teacher. This is a passive learning. Okay, here a special kind of learning called active learning, where the learner can interactively query a teacher or a expert to label some unlabeled data instances with the desired outputs. So here it can learn through an experience or a teacher. So it can be both. It can make use for learning purpose. It can make use of supervised learning or unsupervised learning, or it can learn by itself. That is called as self learning. Reinforcement learning is an example for self learning, where it makes a moves by itself. A reward will be given based on the feedback it has received. It will update and then it will start making the predictions. Then learn to solve problems. Learn to solve problems. It's a type of cognitive learning. Here, where learning happens in the mind and it will devise a methodology to achieve a goal. So that is, with the help of cognitive skills, it will try to solve some of the problems. Like how the human thinks and solves the problem, the same way the machine is made to think and solve some of the problems. And learning by generalization, that is learning by generalizing explanations. Generalizing explanations. It means it is also called as explanation based learning. In this method, it exploits the domain knowledge from experts to improve the accuracy of learned concept by supervised learning. So here the machine learning models can make use of any of these techniques to predict the outcome. So it can make use of supervised or unsupervised or reinforcement learning, or it can make use of some of the convolution neural networks or artificial neural networks algorithm to make some of the predictions. So anyhow, it is a combination of different ways of learning with the help of algorithms and sample data set. It comes up with a hypothesis called as g of x to make the predictions. So this is about the different types of learning. So here there are many questions which arise, that what type of questions to be answered while the system is learning. So that we'll discuss in the next video. Thank you. Please don't forget to subscribe to my channel